In this video, we're going to go over what we need to be able to use the Spectrovis unit to measure absorption. What we will need is going to be the Spectrovis unit, then the LabQuest to actually collect the data, and we'll also need a cuvette filled with distilled water that will serve as our blank, and a cuvette with the sample for which we're going to measure absorbance. The first step is going to be connecting the Spectrovis spectrophotometer to the LabQuest, and for that we need a USB cable. It should be part of your the equipment that you have. So look for the USB connectors. It has a regular USB and a smaller size USB. So that is going to be used to connect it. So for the Spectrovis, you're going to use the USB connectors. They come in two sizes. The smaller one is the one that fits into here. The other one, this one here, will connect to the LabQuest. So let's start by connecting the USB here. Okay, and then we'll bring in the LabQuest, and the connector is going to be here. So we're going to take the USB cable and connect it to the LabQuest. So the LabQuest will light up. If there are, not all the LabQuests in the laboratory have all these features, so you might not see a light on the outside, but if you look on the inside, you should be able to see the light that is shining right here through this here. There's also, if you look at it more carefully, there's going to be a hole at the bottom, and that is to prevent any spill to go into the instrument, so it will drain on the back. So I can put in my finger here. That's on the other side, on the opposite side. That's a drain hole, just in case. So please be careful not to spill things into inside the instrument. Anyways, okay, so our cuvette is going to go in here, and the signal is going to pass on to the LabQuest. So for the LabQuest, if you're not at home, you can start by tapping home, and then use the stylus. Use the stylus to go into the LabQuest app. So for measuring absorbance, and we're going to, in this experiment, we're measuring the full spectrum. So you should see here the mode in full spectrum. If this doesn't read full spectrum, you can tap on it, and these are the different modes. So as you can see, that says full spectrum, but you might find yourself on a different one. Let's say it's time-based. So when you come here, you need to click on here and then to open the drop-down menu and select full spectrum, and then just tap OK. So that will read full spectrum if it wasn't. Again, to use this unit, use only the stylus provided. Do not use a pencil or a pen, because they will damage the touch screen. If you have never used the LabQuest, you will notice that it has a very soft screen, and that can be easily scratched. So you can use your finger as well. There you go, and I can tap OK because I'm in full spectrum. And so tapping with your finger is also possible. It's more convenient to use the stylus. Okay. So now that they are connected, and we know they are connected because I can see the light in here. The light that is shining in there, that's the light. So the light comes out from here, is going to travel across this opening to this side, and when you see this triangle here, is where the sensor is located. Now that our instrument is calibrated, we can collect the data for our sample. So to do that, we're going to switch the distilled water, or the blank that we used for the calibration, by the sample, and we'll put it again in here, and notice the ripple surface is facing us. Now we are ready to collect the spectrum, collect the full spectrum. So what we're going to do is to tap here for run. And that is going to collect the data. Notice that the curve doesn't seem to change. It should be stable, and it should. Sometimes it's so stable that we forget that we're still running the sample. The button to be able to stop it is here, and if we don't stop it, then a lot of the features, a lot of the menus are not going to be active. So we need to stop the collection once we have a stable spectrum, and press it again, and you will have stopped the collection. Notice that this is a curve. It has two maxima, one in about the orange color, and the other maximum is here on the violet color. So this looks good and gives us two local maxima for us to work with for some experiments. In this experiment, we're not going to worry about where the maxima are. Okay, so we have already done the collection, and we have the spectrum. Now we'll go into the XY, and let's say we want to find the absorbance at 680 and 710. So what we're going to do, here's the wavelength. So this is the X and this is the Y. So we need to scroll up, not scroll up, just move this down to 680. So the closest one, it's not exactly 680, but the closest one is 680.30, and 0.382 is going to be the absorbance that we get for. So that's the absorbance at 680. Now we want the absorbance at 710. We need to keep scrolling to 710. And again, we might not find exactly 710, but the closest is going to be 710.40. Actually, 709.7 is closer to 710, so we'll go with this one, and that is 0.129. So if the sample that we have analyzed is a known concentration, then what we could do is take an unknown, a solution that we don't know the concentration of, and put it in here into the spectrophotometer again, and collect the new absorbance. So to do that, we're going to go again to sensors, and we're going to start the collection again. I have switched the samples, so it's asking me whether I want to discard them. Yes, I want to discard them because I already have the absorbances at those points, and you can see that this is a smaller curve, so it's a more dilute solution, and it's stable, so that means I can go ahead and stop it. Notice that automatically auto-scales it, and then we can go over the XY table and again look at 710. So again, 709.7 is closer, so that's 0.07. So they have noticed that the absorbance is weaker because it's a more diluted solution, 0.070. And the one at 680 is 0.211. So once we calibrate it, it's just a matter of coming here and switching the cuvette to any other sample that we want to analyze.